Hey, welcome back. This is College Algebra, and we are talking about the conic sections now. So the first one is the ellipse. One thing about these things, what the heck are they? Why do we care? Well, you can use these guys to model the orbits of any objects. So the objects like satellites that orbit around the Earth all follow these kind of patterns. So highly important in today's society. So let's get in there and take a look. We'll begin with a definition of the ellipse. The ellipse is defined to be the set of all points P, set of all points P, such that the distance between P and these things called foci, the sum of these things is equal to some constant. Okay, and I'll explain what that means. So it's equal to 2a. So first off, what are these foci? So we are going to have a picture and a lot of things to define. So here's my xy plane, drawn very poorly. And then there's going to be these 2 points, focus 1 and focus 2. Okay. Traditionally, we will locate them at position C on the x-axis. So this first guy, we could call him C sub C comma 0. This other guy, negative C comma 0. And let's make this one F2, I guess, and this one F1. So those are the foci. All right. So to say that the sum of the distances between these points, just random points in the plane, to these foci is a constant means kind of like you take a piece of thread, right? So I can even draw a piece of thread that has a constant length, right? And then I take some thumbtacks and I tack the piece of thread down. Then I take a pencil and I push that piece of thread kind of taut, right? So you can kind of imagine taking a pencil and then pushing it until it gets really tight, right? And here's my pen or pencil. Then if you do the process of kind of scribbling all over the place based on this idea, the scribble that's going to get traced out is going to, believe it or not, have this kind of circular shape to it. And that shape is called an ellipse. Okay, so if you were to scribble out based on that blue kind of thingamajig, you're going to get this shape. Should look like basically, Stewie from Family Guy. It should look like his head. Okay, so there's that. This thing is centered at 0, 0. This point right here and this point right here, I call those the vertices. This vertex is always given the letter A, so it'll be located at A0. And this vertex over here, so these are vertices. Vertex. This vertex over here will be at location negative A0. Okay, and then these two other points on the y-axis will be given the letter B. So this will be at 0B, and then this point will be at 0, negative B. I don't remember if there's a name for those points. It may be in the book. I don't remember off the top of my head. The longer axis, so that the length on the x-axis from one vertex to the other, that's called the major axis. And right now it's kind of oriented horizontally, but you can have the major axis oriented parallel to the y-axis as well. So the major axis, half of that is called the semi-major axis. Okay, so sometimes if you're an astronomer or something, you may see the term semi-major axis for half of it. And then the minor axis is just the shorter one. So here we have the minor axis. And of course you could have the semi-minor axis as well. Some other facts: B is always going to be less than A. B is always less than A. There's a relationship between A, B, and C. Okay. If you were to, so again, let me draw another picture here. If you were to kind of take the string that's attached to focus 1 and focus 2, and then push it really tight in the Y direction, so your pencil would be right here pushing the string tight. This distance right here is going to be C, right? So likewise, this distance is also C. This distance right here is B, okay? And that's just given from the coordinates that we've defined. Okay. And then finally, the length of the string is 2a. So the distance on the hypotenuse side here, if you think of it that way, would just be 1a. And then likewise over here. Okay. Because the length of the total string going from here to here is defined originally in the definition PF1 plus PF2 as 2a. Okay, so what do you have there? You have a right triangle, and then that tells you that how they're related, right? So what do we have? B squared plus the legs squared added together equals the hypotenuse squared. And usually the way we work with this formula is we solve it for C. So C squared equals A squared minus B squared. Because in the equation, you're usually going to see A and B, and then C will be kind of unknown. Okay, so you can solve this for any variable you want, but usually this is the formula that you're going to use. Okay, usually. Okay, so that's an ellipse centered at the origin. So right now the center is at 0, 0. Centered at the origin with the major axis parallel, basically on top of the x-axis. Okay, and our formula for this orientation, the formula for that ellipse, is going to be x squared all over a squared plus y squared all over b squared equals 1. Okay. Okay. The other orientation. And you could think of this kind of just tossed like a football into the xy plane, sitting in any orientation. But for us, we just worry about two orientations, the first orientation I gave you, and then this other orientation where the foci are on the y-axis. Okay, so you have this kind of shape with the foci here, and then the vertices here and here. So these points will be at 0, C, and then 0, negative C, and the vertices, of course, 0, A, 0, negative A, and then these other points given B as their location, the variable B. Okay. So in this orientation, the major axis is on the y-axis, and the minor axis is on the x-axis. Right, so then the minor axis is down here. And the formula is different. Okay, the formula this time will be x squared all over b squared, okay, plus y squared all over a squared equals 1. Okay, so in general, it's the bigger number tells you the orientation. So, for example, if you had x squared all over 36 plus y squared all over 4 equals 1, this would be oriented with the major axis on the x-axis because the 36 is with the x. The bigger number is with the axis that the major axis is on. Okay, so another example, x squared over 25 plus y squared over 49 equals 1. So in that case, your orientation will be with the major axis on the y-axis, okay, because the bigger number is with the y variable. Okay. Okay. So okay. So the first thing we want to do is just be able to graph these guys. So let me look at that. Let's look at an example. I guess this is number 4. Graph and locate the foci. And I'll also locate the vertices. Okay. So the problem given in the book is x squared over 16 plus y squared over 49 equals 1. Okay. So first thing we want is the a, b, and c value. The a is the bigger number, no matter what. It doesn't go by, you know, which is one is with the x, which one is with the y. It's just whatever's bigger. So here a squared is 49. So a is the square root of that is just 7. Okay. B squared is 16, so b is 4. And then for the foci, we're going to need the c value, so we just use the formula from above. You have 49 minus 16, which of course is square root 33, which is approximately 5.7. Okay, so going ahead and drawing it, I note the orientation is with the major axis on the y-axis. So the a value is 7. 1, 2, 3, 4, 5, 6, 7 is right here. And then 1, 2, 3, 4, 5, 6, 7 is the other vertex. So vertex, I guess call it 1, is 0, 7. Vertex 2, 0, negative 7. And then we need the foci. So those are at about 5.7. 1, 2, 3, 4, 5.7. And 1, 2, 3, 4, 5.7. It's about right there. Okay, so those foci, I'll say foci 1 is at 0, comma, root 33. I'll just write it with the square root. And then foci 2 is at 0, negative root 33. And then finally, the other points of interest on the x-axis at 4 and negative 4. So there they are, and then we just connect the dots. Okay. Okay, let's look at another one. This one is kind of rearranged in a weird way, so it doesn't look like the equation of an ellipse. So what I do is rewrite it as x squared plus 4y squared equals 1. And then it needs to be x squared over a squared, y squared over b squared, or vice versa. So what you do here is just multiply everything by 1, well, you can't even do that. If you multiplied everything by 1/4, then you would have a 1/4 on the right. So the trick is going to be to rewrite 4 as 1 over 1 over 4. Okay? In which case you would get y squared over 1/4. Okay? So again, what is 4 is the same as 1 over 1 over 4, right? Because 1 over 1 over 4 is the same as 1 divided by 1/4, which is the same as 1 times the reciprocal of 1/4, which is, of course, just 4. Okay. So the a value, you know, if you don't notice, there's a 1 with the x squared and a 1/4 with the y squared. So the bigger number is the 1. So that's going to be your a. So square root of 1 is just 1. And then the b value will be from the 1/4. So that'll be 1/2. And then the c value, you use your formula. C is a square root of b squared, a squared, sorry, minus b squared. So this will be the square root of, whoops, b squared, not to the 4th, 1 minus 1/4, which of course is square root of 3/4, which of course is square root of 3 over 2. Okay. As a decimal, for graphing purposes, 0.866 about. Okay, so let's go ahead and try to graph this thing. So this time, the bigger number is with the x, so the major axis is on the x-axis, and that's also then where your foci will go. Okay, so here's, I'll make this 1, negative 1 and positive 1. Okay, so the vertex will be at 1, 0, and negative 1, 0. So the vertex 1, 1, 0, vertex 2, negative 1, 0. And then my foci are on that same axis. Okay, so there's foci 1, foci 2. So I'll make foci 1, 0, comma, negative root 3 over 2. Foci 2, 0, comma, root 3 over 2. And then on the y-axis there, we're going up by 1/2. Right? And then connect your dots. And you have your picture of an ellipse. Okay. Okay. There's other types of like problems. For example, find the standard equation of the ellipse satisfying the given conditions. So like number 28. They'll tell you information, and then you got to figure out the equation. So the foci they're telling you is at 0, -3, and then 0, 3. And then the vertices they're telling you are at 0, -4, and then 0, 4. Okay. So from this information, we note because the vertices are given by the A values, that A must equal 4. And because the foci are given by the C values, C must equal 3. And A and B and C always have to be positive numbers. Okay. So from here, we can use our formula from way back in the day when we first started talking. B squared plus C squared is A squared. Okay, so we have B squared plus C squared is A squared. And I'll probably allow you to use a formula sheet of some sort, but I'll probably write up the formula sheet, okay, for the I think that would be the final exam. No, there's still another test. Is there another test? I'm thinking it's the final exam. I'll probably give you a formula sheet. Okay. Okay. So, anyways, you could solve then for the B value. So it'll be B squared plus 9 equals 16. So B squared will equal 7, and then B will just be root 7. Okay, and then we just plug everything into our formula. So note the orientation, of course. So in this orientation, the bigger number is going with the y, right? Because the major axis is on the y-axis. So x squared over a squared plus, x squared over, in this case, b squared, which is square root 7 squared, which would be 7, plus y squared over a squared, which will be 16, then equals 1. And that would be your answer. Okay. Okay. Not all of the ellipses we care about will be centered at the origin. Just like with circles, we can move them around. So we want to look at those scenarios, those cases. Okay, so ellipse not centered at the origin. And let's take a look. Okay, so here is a case. We have the major axis parallel to the x-axis, so our foci would be like in there, and then we have our center, and the center we're always going to put at h comma k. So center is h comma k, so the letters h and k. The formula for this scenario, and I'm going to put in some helper information. So this is located at H, this is located at K. The formula is kind of like with the circle. You just put x minus h squared over a squared, and then plus y minus k. It looks a lot like a circle, right? And a circle is kind of an ellipse, I guess. B squared equals 1. It's an ellipse where A and B are equal, but A and B can never be equal, so a circle is not technically an ellipse. Okay. So anyways, to get the vertices then, what you're going to do is kind of move from H in either direction. So the vertices, you start with the center, right? So you'll have H comma K, and then what you're doing is moving back and forth by A. So you have to kind of manipulate the x coordinate, but you're still going up by K. So you're not doing anything to the y coordinate. Okay? So it's going to be H plus or minus the A value. A plus A will put you over here. H plus A will put you over there. H minus A will put you over at this guy. Okay? And then you do the same thing for the focus, or the foci. So for the foci, it's H, and then you're moving left and right by the C value, right? So H plus or minus C. And then for the other vertices, you're just moving up and down by B. I don't remember what they're calling them. I'll just call them the minor vertices, for lack of better names. Vertices. And in those cases, what you're doing is manipulating the y coordinate up or down. So you have to go up by b or down by b, right? So the h isn't going to change, but the k will. Okay. Okay, the other orientation then is when the major axis is parallel to the y-axis. Okay, so that'll be something like this. So there's our points of interest. Okay, this will be h, and then this will be k. So the formula this time, x minus h squared all over b squared, and then plus y minus k squared all over a squared equals 1. And then the other formula is just to remind you, c is equal to the square root of a squared minus b squared, and then b is always less than a. So if I was making a formula sheet, I won't write everything out. What I'll do is put like hints. Okay. Okay, so for the vertices this time, what you're doing is moving up and down. Okay, so h, the x-coordinate, isn't going to move, but you'll move up and down by a to get to the vertices. So it's plus or minus, the y value is what you're moving up and down, so you're not the h, but the y. Okay, so h comma k plus or minus a, and then the foci are the same spiel, so it's h comma k plus or minus c. And then for the other vertices on the minor axis, the minor vertices, I guess I'm calling them, minor vertices, you'll manipulate the x coordinate, right? Because you're moving back left and right by not a, but b. Okay? So it'll be h plus or minus b comma k. All right. Okay, so let's try one or two of these types. So the first type is just graphing and locating the vertices and the foci, the center of the vertices and the foci probably. So x minus 3 squared plus 9 times y plus 2 squared equals 18. So the first thing I'm going to do is divide everything out by 18, believe it or not. So I'll have x minus 3 squared over 18 plus 9 times y plus 2 squared over 18, which is the same as 1 all over 2, and then that'll equal 1. Okay. So the center, you just read off of the formula, right? It'll be 3, negative 2. I need the a, b, and c values. So the a value is from the bigger number, so that would be square root 18, which of course is going to be 3 root 2, which is approximately 4.2 something. Okay. The b value is the square root of 2, which will be 1.41 something. And then the c value we get from our formula. C is equal to the square root of b squared minus a squared, so 18 minus 2, which is, of course, the square root of 16, which, of course, is just 4. Okay. So the orientation this time, and I need to be a little careful, where is this thing centered? It's 3, negative 2, so it's kind of in the fourth quadrant. Okay. Kind of. And right, so the center is at 3, negative 2. 1, 2, 3, negative 2. And then to get to the vertices, I'm going left and right because of the orientation by 4.24. Okay, so 1, 2, 3, 4, 5. 4.24 is right here. 1, 2, 3, 4, 5. 4.24, put it about right there. For the c values, it's by 4, so 1, 2, 3, 4. And then 1, 2, 3, 4. And then up and down by b, so 1.41, it's about right there. 1.41 is about right there. So I'm sort of smushing this in here, I apologize. And then let's connect the dots, I'll do it in blue. So get this kind of UFO shape. Right. The formulas for the focus and the vertices, you can kind of just use those formulas from above. So the main vertices will be by moving in the x direction. So it would be 3 plus or minus 3 square root 2, comma, negative 2. The foci, then you're moving by c, so you go 3 plus or minus 4, comma, negative 2. And then for the minor vertices, I'll just call it MV, you're moving up and down. So you're manipulating the y coordinate, so it'll be negative 2 plus or minus root 2. Okay. They can make these problems a lot harder with completing the square. Let's look at one more before we hit that. Let's look at 44. So you have x minus 4 squared all over 4 plus y squared all over 25 equals 1. Okay, so in this problem, the center is going to be at 4, comma 0. And then the a value is 5, the b value is 2, and the c value is the square root of 25 minus 4, which is the square root of 21, which is about 4.58. Okay. The bigger number is with the y variable, so it's oriented with the major axis parallel to the y-axis. And in particular, I'm in the, where am I? I'm on the x-axis. Okay, so it's kind of in this first and fourth quadrant. So 1, 2, 3, 4. 4, 0 is the center. And then I'm going up and down by 5. 1, 2, 3, 4, 5 to get to the vertices. 4, 5 to get to the vertices. So if you want to just get the vertices out of the way, it'll be 4, comma 0 plus or minus 5. And then the foci will be 4, comma 0 plus or minus root 21, which of course is 4.58, which is just below 5. And then back and forth, so for the minor vertices, you're manipulating the x coordinate. So it'd be 4 plus or minus 2, comma 0. So 1, 2, 1, 2, back and forth like that, and then connect the dots and you have your graph. Okay, usually the universe will not be nice enough to give you the standard form right off the bat. Okay, so the standard forms being this guy and this guy. And in those cases, you'll have to complete the square to even have a hope of graphing it. Okay, so section 3, completing the square first. And we'll look at problem 53. So I have 9x squared plus 16y squared minus 18x plus 64y minus 71 equals 0. Okay, so what do? I'm going to collect the x stuff together. 9x squared minus 18x. Collect the y stuff together. Plus 16y squared plus 64y. And push everything else to the other side. Next, I need to make sure I have a 1 leading coefficient. In other words, I have to factor out a 9 from those first two terms. So x squared minus 2x, and I'm going to be completing the square, so I'm going to put plus blank. Okay, and then plus, I have to factor out a 16, so I'll have y squared plus 4y, and then I'm completing the square, so I'll go plus blank. On the other side, I'll have 71 plus blank, kind of plus blank. I say kind of because it's not like whatever I put in the blank is going to go over here. So there's still one other bit of thing we have to do. Okay, so anyways, completing the square, what you do is go b all over 2 and then square that, right? Okay, so in the first case, it's negative 2 all over 2 squared. Negative 2 over 2 is negative 1. Squared is 1, so that goes in the first slot. And the second slot, I'll have 4 all over 2 squared. 4 over 2 is 2, and then 2 squared is 4, so I put a 4 here. I do not put 1 and 4 on the other side, and it's because of that 9 and the 16. Look, if you were going to redistribute, you would have 9 times x squared, 9 times negative 2, 9 times 1, which is 9. So really what you did in the long run is add in 9. you added in 9 on the left. You didn't just add in 1. So on the right, you're adding in 9. And then the other one, did you add in 4? No, not really, because if you distributed this, you would get 16 times 4. So really what you did was add in 64. Okay, so you have to be a little bit careful. Okay. Let's go ahead now and factor. So I'll have x minus 1 squared plus 16 times y plus 2 squared. On the other side, I have 80 plus 64, which is, I'm going to cheat a little and look at my notes, 144. Then you have to divide everything by 144. So you'll have x minus 1 squared. 9 over 144 is the same as 1 over 16. Then plus y plus 2 squared. 16 over 144 is the same as 1 over 9. And on the other side you have 1. Okay, so our center is at 1 comma negative 2. Our a value must be the bigger value is 4. Our b value is 3. It's oriented with the major axis parallel to the x-axis. And then our c value is the square root of 16 minus 9, which is the square root of 7, which is approximately 2.65. Okay, so 1, negative 2 is in that fourth quadrant. So I'm going to kind of do my axes like that. 2, 3, 4, 5, 6, 2, 3, 1, 2, 3. So 1, 1, negative 2 for the center. And then to get the vertices, because it's the x, it has the bigger number with it, you're going left and right. Okay, so it's 1 plus or minus the 4 comma negative 2. So 1, 2, 3, 4, 1, 2, 3, 4. And then for the foci, you're going 2.65. So 1, 2.65. 1, 2.65, and then you're going up and down by 3. So anyways, we get the foci 1 plus or minus root 2, comma negative 2, and then the minor vertices you're going up and down. So it's 1 comma negative 2 plus or minus 3. So up by 3, 1, 2, 3, and then down by 3, 1, 2, 3, and there you go. Okay, really quick at the end here, let me just go on my math lab. You may not prefer to watch this part. That's okay if you would rather just start doing homework. I need to weed out some of the questions. Obviously, I have too many questions here. I always do that. I always go through and kind of make sure I'm not giving you too many. So these are just graphing. Okay, that's great. Let's skip ahead a bit, see if they have anything weird. Okay, sure. So here's one that's kind of a story problem. Find the standard form of the equation of the ellipse with the following conditions. So let me move things around a bit so I can kind of have my sketch pad and the question out at the same time. Okay. So they're telling us, this is problem 33, they're telling us the major axis has length 14. The minor axis has length 10. And the center is at negative 5, comma 2. Okay. If you think about the orientation of this, not the orientation, but thinking back to when we first originally defined everything, the major axis, and it tells you the major axis is on the vertical axis here. You know, depending on where it's, I know it's, I put it in the wrong place. So it's at negative 5, 2. So drawing a picture ain't going to hurt, right? So negative 5 and then up 2, maybe it's over here somewhere. and it's oriented like this. You know it's oriented that way because it says the major axis is vertical, okay? And then the minor axis won't be. So the major axis is 14. But anyways, what were these points? You know, how did we get to these points? Well, we went up and down by A. So the A value is going to be half of the major axis. In other words, 2A, the length of the major axis is actually 14. So A will equal 7. And then 2B is the length of the minor axis. In this case, it'll be 10. So B will be 5. Okay. And then you could just go x minus -5 or x plus 5 squared all over 25. Okay, the smaller number goes with the x variable because of the orientation. And then plus the y minus the 2 squared, and that'll be all over 49, and then that'll equal 1. Okay, and then typing this in is going to be a pain as well. So x plus 5 squared all over 25 plus another fraction y minus 2 squared all over 49. All over 49 equals 1. Check answer. Yay. All right, so major axis is always going to be 2 times A. And then the minor axis is always going to be 2 times B. Okay, the moral of that story was that. Okay, let's look at another one, 35. Find the standard form of the equation of the ellipse given the conditions. The endpoints of the major axis will be at 8, 12, and then 8, 6. So this is the major. And then the endpoints of the minor axis are at 10, 9, and then 6, 9. Okay. So again, you could draw a picture. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You may not want to draw a picture. So this is getting annoying. 8, 12, and then 8, 6. So it's oriented with the major axis in the vertical direction. So you'll have the bigger number with the y variable. Okay. Sort of setting up my work here. Okay, you can find the distance of the major axis just by taking, figuring out this length here from 6 to 12, and that's equal to 2a then. So 2a will equal, yes, 12 minus 6, so 2a will equal 6, so a must be 3, and a will go with the y variable. In between those two, so you can find the midpoint, and that will give you, well, anyways, 8 must be it's clear to me that 8 is h, and then 9 is k. So you could take the midpoint of that, and that would give you the k value, which would be 9. So the midpoint, you just take 12 plus 6 divided by 2, right? So it would be 18 over 2, which is 9, but you could also see it in the second set of coordinates. So yeah, x minus 8 and then y minus 9. I need the b value, so that's basically 2b will be the 10. This time you go 10 minus 6 from the other ordered pairs. 2b is 4, so b is 2. So that denominator will be 4. And then plop it all in. X minus 8 squared, oops, minus 8. Someday I'm going to be able to type this in correctly. Squared all over 4 plus our fraction y minus 9. Oh, crud. Frickin'. Plus fraction y minus 9 squared all over 9 equals 1. Okay, so graph, give the equation. I think that's good enough for now. I'm going to go in there and try to delete some of the questions I didn't go over and just whittle down the number of exercises. There's a ton of exercises. This stuff will come up again once you get to the end of Calculus 2 and then big time in Calculus 3 again. So you won't see it necessarily in Calc 1 if you go on there. If you're not taking any more math, you'll never see it again, probably. It's very sad. Okay. We'll stop it there, and thanks for watching, and I will see you next time.